friends can join us. All right, so lesson 18.3, triangle proportionality theorem. All right, so we're going to work on proving the triangle proportionality theorem and its converse and apply. So when it says converse, what does that mean? Well, they got the shoes. And so with the word converse, what are we doing with our if and then part of we're switching them. All right, so we're back to Clarissa and her national park needs. So Clarissa needs to find the distance across a lake in the national park. She locates point A, B, C, D, and E and takes the measurements shown. She thinks she can use similar triangles to find the distance. All right, so if line MR is parallel to segment ST and the figure below, explain why triangle MAR is similar to triangle SAT. So what I would like for you to do is look at number 1, 2, 3, and 4 and work those out with your neighbor or a person in close proximity to you, and then we'll discuss them. So we're kind of refreshing the information that we talked about last week about similar triangles when we have one inside, and that was with your homework, right? Proving triangles were similar when you had, either vertical angles or a shared angle. So we're going to kind of go along with that, but now we're bringing in parallel lines, and so I've moved my papers. There's some parallel lines and angles over there, and then that green poster above the table there has your special angle pairs. So use that information. What do you know when lines are parallel? What's that tell you about angles? About the corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, and use that to show that the triangles are similar. So looking at number 1, walking around and talking and looking, there were some different approaches for showing that triangle AMR and triangle ASC that are similar. So looking at these, we're only given one bit of information. We're given that MR is parallel to ST. So what are the approaches? So we have 3 options. What are our 3 options to show the triangles are similar? We have angle, angle, side, angle, side, 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 side. All right, so looking at this, do we have any side information? No. So we can pretty much eliminate that one. We still don't have any side information, so we're not going to use that one. All right. What angle information do we have? All right. So Sam said shared angle. What do we know about angle A? Both triangles have it, right? So is angle A going to change its size from one triangle to the other? No. So we can say that angle A is congruent to angle A, and what's our reason? What's the reason that those 2 angles are congruent to each other? Reflexive. What else could you say? It's a shared angle, right? So you're going to say, shared angle. That would work in this class. But the official is reflexive property. All right, so that's 1. But this says angle, angle. So how many angles do we need? 2. So what's another one? Since we have parallel lines cut by a transversal, what can we do? We have corresponding angles. We know which one did you choose? All right, so we have angle AMR is congruent to angle AST, and our reason that we know that that's true? corresponding angles are congruent when lines are parallel. All right, so since we have that, which of our similarity criteria can we use? Angle, angle. So these two triangles are similar by angle, angle, similarity. All right, good there, right? So we just did a quick little proof. That's exciting, right? Woo! All right, so knowing that corresponding sides of similar triangles are proportional, complete the proportion. So side AM, that's this side here, corresponds to AS, which is the big side, and then AR corresponds to what? AT. So now we're just substituting into the proportion we just created, and what did you determine the length of RT to be? All right, so let's set it up. So AM, what's the length of AM? And then AS, what's the length of AS? It's MS. So what's AS? What do we have to do to get the length? Oh, add them together. So what is 12 plus 9? We have to 21, so we have to do some segment addition. AR is 15. So when we solve this, are we going to get RT? What are we going to solve this to get the length of? AT. So once we solve for AT, are we done? No, because we need to do a little backwards work because it's asking for RT. So doing this, what do we get for the length of AT?
12.
So AT equals how much? Well, do we have it?
26.25.
Okay. I heard numbers, but not with confidence. So AT equals 26.25. But is it asking for AT? No, we need to answer the question that's being asked. It's asking for RT. So how do we get RT? If we go back up here, we know AR is 15. And we know the length of the whole thing is 26.25. So how do we find RT? We subtract them, yep. So 26.25 minus 15.
So why did you have to do these like other, like why couldn't you have just done 12 over 9 equals 15 over 18? We did everything but so far.
Okay. How did you do it?
Like we just stuck with AM over AS equals AR over 18. So then we just did 12 over 9 equals 15 over 18.
Okay, so you changed, instead of doing AS, you did MS.
Oh.
Right?
Yes.
But since all the sides are proportional, does that work? Yeah. So just make sure you make a note to yourself what you did, explain to yourself what you did, so when you go back and look at it, since it's not following what the book has, make a note. But because all the sides are increasing at the same rate, essentially you're finding the scale factor, right? And so it's going to work. So now it says if MS is 8 and AR is 25 and RT is 10, determine AM. Okay, so you got AM equals 27. Did everybody get that, regardless of how you worked it out?
Oh no, I got.
All right, so let's look at it. So we have. So we'll set it up here. So AM is what we want to find. AS would be AM plus MS, right? So I'm going to let AM equal X if that's okay. Is everybody okay with that? AM equals X. So I have X and X plus 8 down here. AR is 25 and RT is 10. So since AT is AR plus RT, this is 35. Is everybody okay with what's going on so far? Alright, so now we're just going to cross multiply and divide. Woo! Not what I wanted. So now we're going to cross multiply, so 35 times x equals 25 times x plus 8. So I have to distribute, so I have to sprinkle that 25 times inside everything. So 25 times x, 25 times 8 is 200. And then we use algebra. So I have 10x equals 200. So I get x equals 20. Alright, so that gives us x for 20. That means that the bottom here is 28. So double check your math. Double check your math. AM should be 20 and AS should be 28. Check your math.
Oh.
Okay. Alright, so AM equals 20. Alright, how are we feeling so far? Alright. Alright, so complete the proof of the triangle proportionality theorem. So here we're given, we have to look at what we're given, and we want to prove that B over A equals C over D, that B over A equals C over D. So the triangle proportionality theorem is a line parallel to a side of a triangle intersects the other two sides, then it divides them proportionally. All right, so looking at the two-column proof, we have triangle PIE and triangle RIM with blank lines parallel. So what's going to go in the blank lines? Line RM and side PE. And watch your notation because this is a line that has arrows on both ends, but PE is not a line, it's a segment. It has a definite two definite endpoints. All right, so now we need to fill in our statement. We have if two pair lines are cut by a transversal, the corresponding angles are congruent. So what's a set of corresponding angles? All right. So we have angle, is that IRM? So we have angle IRM is congruent to angle IPE. And our reason, they are corresponding angles. And if two parallel lines are cut by a transversal, the corresponding angles are congruent. Now, do you have to put those two particular angles? What's another set that you can have? All right, angle IMR and angle IEP would also work. All right, so for number 3, it left it open for statement reasons, and we have a couple options. So we need to show that at least one more angle, a pair of angles are congruent. Which one do you want to use? Okay.
Or we can do angle I, or whatever that one is at the top.
Angle I. So angle I is congruent to angle I, and our reason that we know that to be true? And then we already said the other one, we could put the other pair of corresponding angles would also work. All right, so now we need to be careful. In number 4, it says triangle blank is similar to triangle PIE. So we need to watch our order. So we're starting with angle P here. So what angle corresponds to angle P in the other triangle? R. And then what corresponds to I? And then what angle corresponds to E? M. Order matters. And how do we know that those two triangles are similar? All right, so we have B over B plus A equals C over C plus A. What can we say that, what rule tells us that that's a true statement, and that's our new one? Triangle proportionality theorem. If a line parallel to a side of a triangle intersects the other two sides, then it divides them proportionally. All right, so it's a new theorem, so where does it need to go in addition to in this proof, in your B? Oh, okay. All right, so from 5 to 6, what are they doing? They're doing multiplication property of equality. And then from 6 to 7, they're simplifying. All right, so from here to here, what are we going to put? And I get, here to here, what they're doing is we're cross multiplying is essentially what they're doing. And then, all right, but from 7 to 8, what's going to go here? It says distributive property. What's being distributed on the left side of the equal sign? All right, so BC plus BB. And then on the right side, all right, from 8 to 9, what happens? All right, so what got subtracted? We have the BD here, right? So that means that we lost the BC. Do we have a BC on the other side? Yeah, we do, right? So CB is the same as BC, so when we subtract it from both sides, we're just left with BB equals CA. So this step here, what did we do? Yep. from here to here, what happened? BD, where did AD come from? BD, AD. So BD, AB. So we have some more triangle proportionality going on, right? Saying BD times over AD, BD over AD equals AC over AD. We have AD going on both sides. So what are they doing? If you divide one side and you divide the other side, are you changing the value at all? No, because you're doing it to both sides, right? So this was subtraction property of equality. So this one is division. All right, and so what happens to the D's on the left side? They cross out. What happens to the A's on the right side? They cross out, and so we're left with B over A equals C over D. And that simplify. All right. So let me get your homework here. So your homework. Let's just do 10. A through F. 11, number 11, and then all 6 parts. Oh, 10, I'm sorry, 11. I know. So page 268, number 11, A through F.